Here's another example of inheritance, and I've added a couple of new things here as well. So let's just go through this inheritance structure real quick. I have a superclass called male, and then I have a subclass called package, and usually the relationship between subclass and superclass, if you use the word is or is-a, it kind of makes sense. So a package is male, or a letter is male. Subclasses are superclasses. A priority letter is letter, or is a letter. I mean, usually if it is a or is, priority letter is a letter. A letter is male. A package is male. You can't go the other way. Male is not necessarily a package. So the subclass to superclass, you can use the word is or is a to kind of go up the chain here. And of course, male is an object. Everything is the subclass of this upper level superclass called object. So let's take a look at male. Now I've added a new thing here. I've decided that I want my male to be abstract. So this keyword abstract, public abstract class male, all that means is that you're not allowed in the tester or in a client class, you're not allowed to create instances of male. And there are various reasons why you might want to do that. Maybe there's really no such thing as male. I mean, this is just, it must either be a package or a letter or priority letter. So this prevents somebody from creating instances of male. Again, in real life, programs are written by by many people, a team of people, so this is a way of sort of controlling what you want done with this class. So abstract means you're not allowed to create instances of male. In abstract classes, you're allowed to have abstract methods. Here's an abstract method called getCost. Now notice abstract methods have no method body. They just have the first line. It's called the method signature. Just the method signature is there. There's no guts to that method. Whereas this toString method is not an abstract method, and I have implementation of it. But abstract methods have no implementation. They just have that first method signature line is what it's called. Okay, anyway, here's an instance variable called ID, and here's my constructor where I initialize ID, and there you have it. My toString, which is you should be very familiar with. Ooh, notice, this is a little weird. Notice my toString method, I return ID, and I return cost by running getCost. Well, that's weird, because getCost is abstract. So how can I run it? Well, I'm actually going to be running getCost in one of these subclasses. I know this seems a little weird, but we will get to that later. All right, anyway, let's take a look at letter. Again, letter is male, and so the keyword that you use here is extends. Public class letter extends male. I've added another variable called cost. So male has a cost, and I used the word final. You haven't seen this before, perhaps. I have a private final variable, private final double cost. Final just means it's a constant. So I'm not allowed to change the value cost. I've declared a constant, unchangeable. And usually as a convention, they write finals using uppercase letters. So 46 cents I would not be allowed, and actually I'll compile this if I did something like cost plus plus, it's going to complain. It says cannot assign a value to final variable cost. I'm not allowed to change that or assign a new value to it. So this is often used if you have something you don't want to change. Anyway, so you're familiar with this. This is the constructor for letter. And I'm initializing the superclass. I'm actually running the superclass constructor, and I'm passing it I. And so here I is getting passed to the constructor, and I'm initializing ID. Just to be clear, even though letter inherits ID, I'm not allowed to access it directly. In other words, I'm not allowed to say, let me just comment this out. I'm not allowed to say ID equals I. If I compile this, what is it? It's complaining because constructor cannot be applied to given types in I. Yeah, no arguments. Anyway, ID is not declared here. ID is in the superclass, so I can't change it directly. I have to call the superclass constructor. Okay, so here is the method getCost, and I'm implementing getCost. It's very easy. I'm just returning cost. That's all I'm doing. It's very simple. This is an implementation of getCost. And one other thing, if I did not have this method, it's going to complain. I'll compile this. What it says is letter is not abstract and does not override abstract method getCost and mail. So if you have a method in a superclass which is abstract, you must implement that method in the subclass unless the subclass is also abstract, is what this is saying. So since letter is not also abstract, I must implement any abstract methods in the superclass. Maybe I should say that again. Letter is not abstract, and therefore I must provide implementation to any abstract method in the superclass. GetCost is an abstract method, so here I am providing implementation for getCost. Okie doke. Let's take a look at the subclass of letter, which is a priority letter. Here's priority letter down here. Priority letter extends letter. You're familiar with that. This is the constructor. I'm calling the superclass constructor and passing it I, which of course is this constructor, which then is calling the superclass constructor of it. So it's kind of going up the chain twice, if that makes sense. This superclass is this guy, which is calling this superclass constructor, which is this guy. So a priority letter is initializing the ID by calling the superclass. Anyway, here in a priority letter, I've decided that a priority letter costs twice as much as a regular letter. So I'm re-implementing the getCost method. Remember, getCost is in the superclass. I'm allowed to re-implement that. That's called method overriding. I'm allowed to override the getCost method. And all I'm doing is returning the super getCost. So it's calling superclasses getCost times 2. So a priority letter costs twice as much. I'm running the superclass times 2. Now, if I did not say super.getCost, it'll compile okay, but I'll run into problems because it'll end up running this getCost. It'll be an infinite loop. I don't want to do that. I want to run the superclasses getCost method and multiply it by 2. Now notice I can't just say return cost times 2 because cost is a private variable in this superclass and I'm not allowed to access it directly. Even though priority letters have a cost, I can't change that value without using a getter here. So that's why I'm using getCost. So hopefully that makes some kind of sense. This is my priority letter. Let's take a look at package. I could close these down here. A package is also mail. So you can see that package, since it's mail, it must implement any abstract classes. Package is not abstract. So package also has a weight. So here I am calling the superclass constructor to initialize ID, and then I'm initializing weight in ounces. Okay, packages have some weight to them. The other thing is, just to be clear, if you're going to have a call to a superclass in a constructor, it must be the first line of code here. If I switch these lines of code, it would complain to me. It will say, I cannot apply to the given types. It's kind of a strange error message, but the point is that you have to call the superclass first as the first line in a constructor if you're going to have a call to the superclass. The rest of this I think is pretty straightforward. This method getCost is supposed to calculate the cost of a package, which I said is 75 cents times the weight. And then I have a toString method. Now this toString method, oh sorry, I skipped one. GetWeight just returns the weight. I guess I should have written this on multiple lines there. GetWeight just returns weight. That's a getter method. Okay, and then finally I have a toString method which calls the superclass's toString method and then just sticks on the word weight with the weight of this package. So what happens is it's actually calling the superclass's toString, which is up here, which creates this string called ID and cost, and then adds on it the weight. The reason I, of course, have to call the toString method is because I can't directly get the ID. I guess I could get the cost using getCost, but I really don't have access to the ID. That's why I'm calling the superclass right there. So hopefully this makes some sense to you. And the other thing, of course, that I had to do was implement getCost. I think I said that already because getCost is abstract in the superclass. All right, so let's take a look at the tester. And I think if I hit compile, everything should work okay. Well, here is my tester. Let me just see if package compiles okay. It should. Okay. Here's my tester. And in the comment section of my tester, I said, note, some of this code does not work properly. Comment out the incorrect code and explain why it does not work. So let's kind of go through this. The first thing that doesn't work is I tried to create a new mail item. I tried to instantiate a piece of mail called L1. Mail L1 equals new mail. You know that's not permitted. You're not allowed to create abstract objects of an abstract class. Remember, mail is abstract. I'm not allowed to create instances of this abstract class. So I'm going to comment this out. That is not permitted. Let's take a look at this second thing. Is this permitted? Am I allowed to say mail L2 equals new letter? I know you're thinking it's a little funny. Why wouldn't I say letter L2 equals new letter? More about that later, but this actually is permitted, and it's permitted because letter is mail, or if this guy is this guy, you are permitted to have this line of code here with a superclass subclass. This is allowed. So if I run this, and actually maybe I should comment everything else out, this will certainly work. And let me just I'll compile this guy. This is totally fine. It will it'll of course run the toString method in L2 is what'll happen here. So I'm no, sorry, not L2, in letter. Let me back up a little bit. When you actually run this thing, it knows that L2 is a letter. So even though I'm calling it mail here, mail L2 is new letter, when you actually run this guy, it says, oh, L2 is actually a letter. It'll try to run the methods in letter. And there is a toString method in letter, so I believe. Oh, actually not. So it'll actually go up the chain and run the toString method in mail. Fair enough. But anyway, this works. Let's take a look at the third example. The third example, this first line is permitted because a priority letter is mail, right? As long as this guy is this guy, it's permitted. And then I run the toString method in L3. Now, priority letter does not have a toString, so which is fine. It just kind of looks up the chain and ends up running the toString method in mail. Okay. The next line, L3.getWeight, that's going to cause a problem because L3 is a priority letter and there's no getWeight method in it. And if I compile this, you'll see it says cannot find method getWeight. Remember, getWeight is only in package. So let's comment that guy out because that doesn't work. Let's take a look at the next thing. If I hit compile, okay, again there's a problem with this getWeight. Again, I made mail P1 equals new package. This is permitted because a package is mail. And you can see that I have two things that I'm passing in. Remember, because a package has, where's package? Package has an ID and weight. So this is okay. And of course, when I run the toString, it runs the toString method in package. This, I had a problem at compile time, because at compile time, it thinks that P1 is male, and there is no getWeight method in male. So in order for this to work, I have to say, hey, wait a minute, P1 is in fact a package. So I will say, and this syntax is very specific. I'm actually adding 2 sets of parentheses. I'm casting P1 to a package, and then I'm allowed to run the getWeight method. This might be a little confusing, and we'll see more about this later. But this is now okay because a package has a getWeight method, and P1 is really a package. So at compile time, it complained though again, because at compile time it thought that P1 was male and getWeight does not exist in male. I know that's a little bit confusing, but hopefully that makes some sense. And then the last case, let's see if there's any problems with the last case. I'll hit compile again. The last case works fine. I'm allowed to say package P2 equals new package, and I'm running the toString on package, and then I'm running the getWeight method on P2, which is a package. Now again, I know you're thinking, why would you ever want to say like male P1 equals new package? Why not just say package equals new package? There will be reasons for that. I mean, you might have some kind of structure like an array or something, and you have to declare it as the superclass, but various items, various elements in the array might be instances of the subclass. So there are reasons why these are not always the same, and it's permitted as long as this is a subclass of this guy. So that was kind of a quick run through of another inheritance example, and I'm using abstract here. And just maybe one more thing to be clear, when I run the toString method on a package, it's a little weird because run the toString method on package, let's say, what it does is it runs the toString, here's the toString method in package. It says, oh, I'll run the toString method in the superclass, which is male. When I run the toString method in superclass, it returns the ID, and then it runs the method getCost. Well, getCost is abstract, so it runs the getCost method on the type of object which you have, which in this case is a package. So it goes back down goes back down to package and actually runs the, where's the getCost method? Oh, right here. Runs the getCost method in that. So again, male has an abstract method called getCost. So this, in the toString, this getCost is run on the type of object that you're currently working on. It could be a package, letter, or priority mail. So hopefully that makes some kind of sense. I did include underneath the link for the video, I did include all of this code so you can look at it again and you can use it to help you on the abstract project, the abstract inheritance project, which is the assignment underneath this. All right, go for it.